Uh, let's stop recording now.
What? All right, guys. So I had a few questions already from section 1.6. So I think I want to devote some time to go in a little bit deeper with this probability stuff. And then we'll get into 1.7. Also, real quick, while I'm thinking about it, hopefully you'll, well, let's see, I'm just going to say this. When I'm grading the homework, it is kind of unfortunate but true that I hit incomplete more often than I hit complete. So I've caught myself hitting incomplete when I really should have hit complete. So if you look at your homework and it says okay at the top, I should have hit complete, like you're fine. So somebody already kind of called me out. I had hit incomplete when I put okay, and I'm like, oh man, I knew I was going to do that somewhere. So don't take it personal. Just remind me. I'm not. Anyway, I'm just human. I guess that's all I'm saying. So before I get into anything specific, does anyone have any questions about homework? Specific questions, general questions? Got more people coming. Good. All right. I'm about halfway through looking at section 1.6 homework that's been turned in. And from that and the questions I've gotten, I think we need to work a little bit more on probabilities. So I think it's sometimes it's the way the question is worded. There's multiple ways to get at a probability. Can you guys all hear me okay? I've got my fan going in the window. Is everything all right? Okay. It's actually a nice cool morning for once. It's neat. Okay, so I'm going to use my board. I haven't used that in a while. Okay, so we did an example with the chart last time. So let me just give us. So if I knew that 15% of the people in the class is left-handed, right? What's the probability that I randomly pick a person from this class and they are left-handed? So I don't know if you guys, it's either too easy, you don't want to say it, or you think that there's work and you don't know what that work is, or it's too easy and you assume there's work and there's no work to do. I don't know which one it is. What do you think? Oh, oh. Somebody keeps unmuting and then muting.
Okay, maybe 1/3 probability is like.
Okay. So it is that. It is the, I can't remember which the options were. There is no work to do here because the work has already been done. So let me not even answer that question yet. I'm going to leave that blank. Let me show you the second problem. If I had 38 students, you could do it, Jeff. And let's say, yeah, and 6 of them are left-handed. What is the probability I would get a left-handed person? Is there any, if there's 38 students and 6 of them are left-handed, what's the probability So let's see, I don't know, Andrew, where that answer's coming from yet. I think you're answering the first question, which is fine. We'll come back to it. This one should be close to that. I try to make it kind of close to that. How would you do this problem? Okay, thank you, Andrew.
Divided, 15%, about 15.7% chance.
Yeah, and I think your brains might latch on to this problem a little bit better. Humans in general, they're going to latch on because you can actually see some work to do. So you kind of trust the problem because you see work. So don't you have to do, is everybody cool with this? What's the basic idea of probability? It's the amount that matches what I'm looking for out of the total. So how many chances do I have to pick a left-handed person? 6. Out of how many total people? 38. Isn't that an English way to say this? 6 out of 38 people are left-handed in this class. Is everybody with me on that? Does that make sense? You've heard this before. And the funny thing is math goes, oh, hey, shit, that's math. You just said math. 6 out of 38. That's math. 6 out of 38. And I think, yeah, Andrew did the work already, so you can double check. But if you do 6 divided by 38, so it comes out to be 15.7%, so 0.157. Let me stop for a minute. Okay, maybe. Are you guys cool with that second problem? I mean, this was the one that I think more people do because you're so used to having problems that require some kind of work. This first problem doesn't require work because what did somebody do for me that I had to do myself here? I had to calculate the percentage. What did they already do up in this problem? They already calculated it. So there's no work for this problem, right? I really want you guys to get that. If 15% are left-handed, then what's the probability I pick a left-handed person? 15% chance. That's the basic idea of probability, right? As the numbers of something go up in a population, the probability of getting that thing should also go up by the same exact amount. So this would definitely be, so here's an actual class, and we got 15.7% left-handed people. So the difference between this one and this one is on the first one, they already did the work for me. And I think that's why we have some trouble with that. We go, okay, there's got to be some work I got to do. This is a math class. There's always work. No. This is more than just a math class. In fact, math itself is just, are you able to identify when there's a lot of work to do, a little work to do, or no work to do? That is one skill that we have to work on. So in number 1 and 1-6, the first part of it, there is 0 work to do. They tell you the answer. And the second part is, what's the probability I get somebody that's not left-handed in this first problem? Let's probably get somebody who's not left-handed.
85%.
Yeah, if there's 15% left-handed, the rest must be not left-handed. Why don't I just say right-handed? Because you could be ambidextrous. You could have lost both your arms. I don't know. So it's got to just take all the other possibilities into account. Let me stop for a minute. Are you guys, I think, so part of the problem, part of the problem with why there are issues with like number 1 in the homework is because it's too easy. They just give you the answer and your brain doesn't trust it. You're like, this is math, there's a trick. In fact, somebody wrote that. Somebody wrote, I think it's this. If it's not a trick question, I'm like, damn it, it's not a trick question, it isn't. So no matter what level of math you're in, you're always going to hit this kind of problem where the problem is to recognize that there's no work to do. You just have to pluck out the number they already gave you. which is a part of knowing math, is knowing when there's a lot of work to do, knowing when there's nothing to do. Okay, does that help at all? I don't know. Somebody give me a very positive shake of the head. I like that. Always appreciate it. Okay, so let's say this. Do you know what the actual, let me see, I'm trying to help you out with the next part here somehow. So in actuality, 11% of Americans are left-handed. So if I had 60 people, 60 Americans, how many would I expect to be left-handed?
%11 of the population.
Say again, sorry?
11% of the population.
11% of what?
Oh, 60.
60, good. Thank you. Let me stop right there. You guys understand that that's kind of like the first level use of a probability. So listen. Remember back in the day, do you guys remember, or have you heard tell of the days when we actually went into these places called classrooms? And some of the desks were left-handed desks, you know, especially back in the day when you had these horrible desks that weren't really meant for everybody. How do they determine how many of those desks to put into each classroom? Did you ever wonder about that? Probability completely, yeah. What we're just now doing. So if I have a classroom with 60 desks, and so what I need to know is, well, how many left-handed people do I expect to be in this group of 60? So you have to know how to do that. So like Vu said, I think Vu said you would do 11% of 60. Now what, somebody else tell me, what math does that translate into? What math does that English statement translate into?
60 times 1 or 0.11.
Yeah, so I do 11%. So 0.11, right? Because you got to move the decimal once, twice back to make it into an actual number. Of means times 60. Yeah, to be safe, it would be 6.6, but you'd round that up to 7, sure. So if I had a classroom with 60 desks, I should put at least 7 of them as left-handed. In fact, what do you think we would do just to be really careful? Because again, now this is going a little further than this problem requires. Do you think that for every group of 60, there's exactly 7 left-handed people? Some groups might have more, some groups might have less, but overall, they should average to be 7, or 6.6. So to be careful, we would put a couple extra maybe, or maybe they don't give a shit. So they, it depends on how much outcry you want to deal with from the left-handed people. Anybody in here left-handed and had to request a desk ever in your life? No? Wow, okay, you've been taken care of.
I'm
That's
left-handed, but I never had a left-handed desk when I was in school at all.
So you just had to suck it up and make it work.
Yeah.
Yeah, same here.
Say again, sorry?
I said same here.
Okay, so then you weren't answering the question in a good way. You were just saying nobody did shit for me, and I didn't feel like they would, so I just shut up and took it. I understand. I am not left-handed, so I can't. I don't know your plight, but I listen to your lived experience, and I respect it. All right. I like that. Okay. So hopefully this, I could use this always. Always, I could use this always. So there is a problem I want to do from the homework because it's a very important problem. It's number 2 and 3. So, by the way, real quick, do you guys know that biologically, the probability that somebody is going to have a girl baby, not a boy baby, right? So when you're going to have a baby, the probability it'll be a girl is actually a little bit higher biologically, because nature has built into it. It's not like nature has a brain. So if I say nature knows, it doesn't mean like there's a nature that has a brain going, oh, I see. But the way that biology works, it's built in that we understand that more men will die sooner. So what is it the other way around then, Jeff? I forget. Anyway, so the probability isn't really 50-50. I think it should be the other way around. Too bad for us. So it's not 50-50, right? So in the book, in the problem we're dealing with, they actually cite that it's 51.5%. And maybe biologically it's because women make babies, so we need more of them. I don't know. I can't remember. It's been too long. Okay. So, but if there are 535 members of Congress, and there are 51.5% of the population is women, what percentage would you expect to, I mean, not what percentage, but how many women would you expect there to be in Congress?
I put 275.
How'd you do it?
I divided 535 by 51.5%.
I'm almost certain you didn't, because that would not lead to the number you gave me.
Multiply.
I mean, not divided, multiplied. Yeah, sorry.
There you go. Okay. And of course, why? Because this is exactly the same problem I just gave you. It's got different numbers, but who gives a shit? It's a percentage of everybody, and I got a group. So how do I figure out of this group how many are women? Well, I expect 51.5% of 535. That's what I would expect. So that's number 2. Number 3 then says, all right, that's nice what you expect. Here's what actually happened. Now here's where I can really see some of the opinions I get sometimes scare me a little bit. And I'm not trying to push anybody in a certain direction, but I will just sit back and see. Number 3 is an opinion question. So it's almost impossible to get it wrong, but there are answers that are more wrong than others. I'll tell you that right now. Do you think it's because women are just not interested in politics? Do you think that's why? Okay, so I'll let you go from there. So you figure out what this is, and then number 3 says there's actually 104 women. So it says your opinion. What does that say about our country? It's just your opinion. So I am not saying somebody's opinion is wrong flat out. I'm just saying that some are more wrong than others. Anyway, I try not to bring too much politics in this, but okay. I think that's about it. Anyone have any specific questions about the probability stuff, if you've gotten in there yet? Okay. Let me see. Let me see. All right, well, that's all I wanted to say, unless there were other questions. So I'm gonna, if you haven't gotten to section 1.6 yet, get in there. Hopefully what we've discussed helps. If you did get in there, I'm grading them right now. So we'll see. this weekend I was trying to catch up. I got a class that has a quiz tomorrow, so I was trying to do most of their homework. So I didn't quite get caught up with you guys yet. So yeah, I'm in the middle of grading those 1/6s. All right, guys. So anything else before we get back into 1/7? And now this thing is right up on me. All right, I'll just leave it there. It's okay. You guys can't see my dirty kitchen now. All right. Okay, all right. So I don't see any questions. We're going to get into 1/7. We sort of started doing it because we looked at the prep questions. And they were dealing with, so something very, very important. Let's do this. Let me just keep using my board. That's easier. Some stuff you got to really, really know before you even try section 1/7 homework. So somebody help me out. What would this be? Oh, let me do this.
Power 7.
Spotlight.
Yeah. So I think we all, I'm pretty sure that everybody gets this. Or if you don't, you're not speaking up. What's on you, okay? Okay. Since the bases are the same, and I got 2 of these here and 5 of these here, that means I have 7 total. Okay. So I'm pretty sure we all get that basic reality. I like it. Here's something that trips some people up.
Seven.
Yeah, because again, what do you do with the powers? You still add them, but I get people telling me the answer is 7 to the negative 11. That is wrong. Because negative 5 plus 6 is not negative 11. Everybody with me? So this is a really good, all right, I'm going to hold on to what I was just about to say. I'm going to give you a really freaky ass problem next. Yeah. So what is the right answer here? I think somebody said it's 7, because it'd be 7 to the first power, right? Negative 5 plus 6 is 1. So really, what step am I skipping on both of these? I could rewrite this as 7 to the negative 5 plus 6. If I really wanted to use up more of my paper, right? Now let's see who really keyed on what just happened. Don't say anything yet. Just think about this for a minute. What is this? Don't say anything. Don't type anything. Just think.
8 power to 3n.
I don't know. Is everybody able to hear me? I mean, there's always somebody. You're okay, Sam. I was hoping. So yes, because and this is my earlier point that I almost made. Math does not give the first shit what is up here. If the bases are the same and you're multiplying, what do I always do with these? Add them. But for some reason, students think, oh, this must be a new thing. This must, oh, I don't know. I don't know how to handle it. He never told me. Of course I did. You add them. So math doesn't give a shit what's there. It just cares that they're the same base. I add the powers when I multiply. Same base. I add the powers when I multiply. Math doesn't care. We care. So like you said, this will be 8 to the m plus 2m, 8 to the 3. All right, maybe. So like I always do, I just had to push it that one extra step. But this general idea about the process of math, not caring about the specifics. It does not matter what's up here. You just add them. So
Yeah.
what if it was, go ahead, sorry.
You said 8 to the 2 bases are the same. The first m has nothing on it. How'd you get to the 3?
No. Stop. Are the bases the same?
Yes.
Yes. Therefore, I add the powers. What is
Okay.
M? So what is understood to be in front of M?
1.
Why?
1M plus 2. Say again, sorry.
Why is it a 1 there? Why is it understood to be a 1 in front of that M?
Because what is, how many M's have I written here?
1.
1M, okay, so why don't we write it though? It's not a question of where did it come from? It's always there. We just decided there's no point to write it, right? And not we weren't around. Our ancestors did. They all got around, they said, what the shit do we do with this? Why would we write that dumb thing? I can see there's 1M,
Oh, okay.
but there's always understood to be a 1 in front. In fact, what is this? What is M divided by M? Sorry.
1M, I guess.
No.
1M.
No. What's 8 divided by 8?
1.
What's 2 divided by 2?
1.
What's M divided by M?
1.
M.
Oh, it is 1. What is something
That's what I
divided
said.
by itself? What is something divided by itself?
1.
1 whole, yeah.
Yeah, right? So what is M divided by M? 1. And what's another way to see that? If I realize there's a 1 here, don't the M's cancel? Leaving you with the 1 that was there.
Yeah.
So the only time the 1 has to show up is if the letter it's on disappears. Then it needs to show up. I need to remember there's a 1 there. All right. It's amazing how far I can go with any question you ask me. But yes, okay, so Linnell, your basic question was, what, that's only 1M. Okay, but that's 1M. 2 more
Plus
M's.
2, yeah.
3 M's.
Same base. Give me
Same-
3, yeah.
These are like terms. So you're kind of giving away where I want to go next. What if I had this? What you got, John? 5 to the x times 5 to the 3y.
Five to the 3y plus x.
Yeah. So 5 to the x plus 3y, or the other way around. And then you stop. Why could I keep going here? Because these are like terms. Why do I stop there? Because they're not like terms. But the basic idea of what to do did not change. Like bases, multiplying, add the powers. Here I can go one more step. Here I can go one more step. Here I got to stop. But the basic idea did not change. Are you guys picking up on this? Because this happens throughout all of mathematics. And a lot of students think, oh, we're in a different section. So that means everything I just learned doesn't mean shit. And I'm like, no, it has to still be true. Everything you learned has to still be true. And you learn the basic process. All right, anyway, so I'll bring it up more often when we get into other stuff later. Let me think. Well, oh yeah, okay. So that was one level of preparation. One level of preparation for this section was you just remember how to deal with exponents. The next level was something like this. What's the shortcut to rewrite this as a decimal, as a number, not in exponential form? What's the shortcut?
0.00.
Count the zeros the other in the negative sense.
Yes.
And use the one for the first slot. Yeah. Right. So
use the 1 wherever you end up. Yeah. So this is
So
the
7 zeros
negative
and then
power.
8.
right.
The negative power, which means I'm going to move 8 times that.
Left. Yeah.
So I'm going to have 1, 2, 3, 4, 5, 6, 7.
7, 1. Yeah.
That is the shortcut because the long cut is What does a negative power mean?
It's 1 over that.
All right.
Value.
That is all that a negative power means. It doesn't make something negative. In fact, what does a negative number mean? Just like I wrote -2, what does that mean? That's such a beautiful, vague question. Of course I love it. What does -2 mean?
Is it like 2 less than the whole number?
No. Like what situation would that apply to physically?
You owe someone $2.
Yes, kick ass. So this means I owe somebody $2. Owe somebody $2 in the additive sense. What does that mean? If somebody added $2 to me, would I break even? Yes. Because then I can pay that guy off and he's not going to break my thumbs over $2. Jeez, Tony, $2. Sorry, he just wants to break thumbs. This, stay with me. This means the same exact thing, but multiplicatively. This means I'm 8 tens in the whole multiplicatively. I really hope somebody out there understands what I'm saying. So a negative doesn't make a number negative. It means that's how many you owe. Here it is a negative number because it's additively. This does not change it to a negative number. It means I'm 8 tens in the whole. I'm 8 tens south of 1. I don't know. So that's why it gets so small. Because somebody would have to multiply me by 8 tens just to get me back to a whole 1.
Right.
The same way somebody has to add 2 to get me back to 0. All right.
That's
So you
kind of
have-
where I was going at, Jeff,
Gotcha.
when I said, yeah.
I'm with you. So this fraction is this as a decimal, and that's why this is a shortcut. There's no need to go here and there when I can just count back. Okay, maybe. So let me see if I can go one step further with this. So what is this?
$1,000.
10, 2, yeah.
1,
3
all
zeros.
3 zeros. And what is this?
150.
I like it. How much bigger is this than this? How many times bigger?
2 times.
Not just, no, I see what you're saying, Linnell, I do, but it's not twice as big, because then that would mean it'd be 2,000, right? Twice
Right.
this, 2,000.
100.
It's 2 tens bigger. 2
2
tens, so that's 100. I really want you guys to get this. That is the usefulness of looking at, for example, the size of our national debt. It's so big, it's easier to think of if I put it in terms of powers of 10, right? And there's a problem I really like in the book. Can anybody on site oh shit, hopefully they're not the same. I think I counted right. Can anybody on site tell me which one of these is smaller? I mean, quickly. Can you just glance at this and tell?
No.
Shit, no. Right? Our brain just goes, bunch of zeros, bunch of zeros.
They look the same, yeah.
Leave me alone. But if I put each one in terms of 10, what would this first one be? All right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 10 to the negative 13. And what was the second one be? Let's see if I did a good job here. Oh, shit. Why should it be the same? Which is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yay.
Oh,
Which number, okay, you ready? So now you can see the difference. Which number is bigger and by how much? The first one or the second one?
The first one.
First one is bigger, yes. I really want you guys, do you understand why the first one's bigger? Because the first one only owes 13.
Less.
That's
The
negative.
second one owes 14. And how much bigger is the first one than the second one? How many times bigger?
So I would have to say 110.
10. It's 110 bigger. So writing in terms of powers of 10, our brain can latch onto that easy. When you write it like this, screw you. I don't know what the hell. It's a bunch of zeros, right? In fact, there's and I don't know how deep I want to get into this. There's entire civilizations that had no number beyond 3. So when they were counting something, they said 0, 1, 2, 3, many. Because there's theories about how many groups of things can we count without actually counting. So if you saw 2 people, you would just go 2. You didn't actually count them, did you? You guys with me? If you saw 3 people, you just say 3. If you saw 4 people, you just say 4. Around 5, 6, 7, you start having to count. You guys with me? And that's exactly what we saw happen here. I can't just glance at them and go, oh yeah, that one's bigger. No, I have to count which is what this does. That's what this, putting it in this form, it does it for me. Okay, maybe. I mean, the history of numbers, I know. That's not a documentary you'd watch on Netflix. I understand. That's why I'm here. I watch that shit and I eat it up. All the history of math books I have in my room. Holy shit. I'm such a wonk for this stuff. But anyway, I'll stop. I'm not going to do too much of that to you. Okay, so let's get in the book. Wah! If you have the book, holy crap, you're really right up on me. All right. Let me see. Pull up the book. So I'm going to be in section 1.7 in a minute. Where are you? There you are. Okay, let me share this. All right, so you guys should be able to see the book, right? Yes, Jeff. Thank you. All right, so now this is the point I was trying to make up on the board. Now, to be honest, if you glance at those, can't you tell there's one more 0 or something? There's more zeros here for sure. Okay, so that's maybe not the best example. But you can't just glance at it and know that 1 is 100 times as big. So that's the whole purpose of this section is there a better way to write numbers when they have so many zeros in front or behind them? Blah, blah, blah. Oh, yeah. All right. No, I want something good here. All right, so this goes through a lot of what we already talked about. Let me see if I can. Are you working, poor little dude? No, you got to plug in work, Jeff. All right, now you're working. Okay, go ahead. All right, so we have these facts, and you can see how we already discussed the power relates to how many zeros are in a number. Ooh, neat. Stop. Let me see if I can go up here. So if you look, the national debt. Now this is a beautiful example of what we were just talking about earlier. Stay with me. Stay with me. I know this is boring as shit. I'm sorry. Let me see if I can annotate. Yes. Let me make it so you guys cannot also annotate. Too late. All right. So here's 1930, what the debt was. And here is 1985, what the debt was. And let's not talk about where it is right now. So if I wrote these out, they would just have a bunch of freaking zeros afterwards. But since they are written in this form, this is a very strange form. Let's just write one of these out. Can you guys write that number out in normal numerical form? What would that mean? Can somebody help me out? I've got to move the decimal how many times?
Well,
Yeah, is everybody cool with that? I got to move it 12 times. So I got to move it how many times just to get around the numbers?
3.
1, 2, 3. So then how many zeros will I have after that?
9.
All right, cool. Is everybody with me? You have to move it 12 times. We've talked about it a few times already. So you have to know by now the power on the 10 tells you how many times to move the decimal. It's positive, which is why I'm moving it that way. I've got to do it 3 times just to get around those. So I need 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Bam. So what place is that in? Did they tell you already? No. Let's see. This is thousands, millions, billions. Somebody's chatting at me. Trillions, yes. 1 trillion. Okay, stop. So it's almost $2 trillion here. Now, all right. Stay with me. Writing it this way really kind of sucks here because it just gets lost in a sea of zeros. Can somebody tell me, if I said estimate how much bigger the 1985 debt is than 1930? What's the only part of the problem that really matters? Like 1.823 divided by 1.6, well, I would estimate that to be 1. I'm not really sure how good you guys are with estimation, but does everybody get that? I mean, it's basically 1. It's not 1, but it's basically 1. So all that matters then is how relatively bigger these are. We already did a problem like this. So about how many times bigger is 1985 debt than 1930?
100.
How many tens bigger?
Yes.
Yeah,
2
2 tens
tens.
to 100. So that is 100 times larger. And of course, they tell you that right down there. So look at number 1 here. I like this. Earth
That's
is
the
about.
question, Jeff.
Sorry, yes.
What we moved was that 2 tens due to the 10 and the 12 or not?
Yes, 2 tens.
Bigger.
10 times
Bigger.
10, so 100 times bigger 1985 is than
Right.
1930.
Which is equivalent to 100 times bigger, you saying?
100 times bigger.
Okay.
I
Thank
like it. You're welcome. Where'd I go? Oh, so Earth is about this far away from Venus on average, right? Because the distance doesn't stay the same. And about this far away from poor little Pluto, right? Poor little Pluto. Used to be a planet. About how many times further away is Pluto? So this has got a little bit of a difference to it. So let's look at this part of the numbers. If you had to estimate how much bigger is this than this, how many times bigger?
2-ish.
Estimate. 2-ish. I love it. Now look at the powers. How many times bigger is this than this? How many tens?
1,000 or 3.
Sorry?
1,000 or 3 tens.
No. This is 9. This is 7. So how many tens bigger is this?
Oh, it's 2 tens. Sorry. It's 100.
Now let me stop for a minute. I appreciate Cameron answering all the questions, but I want to make sure everybody else gets this idea. If I just look at the powers of the 10, I can tell how many times bigger, how many tens bigger one is than the other one. So this is twice and 100. So it's 200 times as far away. So Pluto is 200 times as far away from Earth as Venus is, right? And we all should know Venus is right next to us, relatively in the order of things. And Pluto, of course, is way the shit out there. All right, maybe. All right, so I have to clear that before I can move on. I'm gonna clear all my scribbly. It's going away. It's probably a good thing, Jeff. All right, go. Now let me move. Blah, 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 blah. All right, so here, just take a minute and do 2 and 3 for me. me see what you guys think. What is the current population? Really? I thought for sure we had more than that. That's 2019. Yeah, we got 330 million right now. Okay. So just to catch up with you guys, because this is kind of going backwards from what we've been doing. Let me see what you picked up on. Do you understand this scientific notation is a number that looks like something point stuff times 10 to the something. So this number right here has to be between 1 and 9. So the whole idea, this is the way I like to look at this. And you know I'm weird. You already know this for sure. So I don't care. I like to look at scientific notation like a 10 vampire. It sucks all the 10s out of something. Right? So it's a very strange vampire. So how do I do that? Well, if I start sucking 10s out of this, which is a very strange phrase to deal with this early on a Tuesday after a long weekend, but does anybody get the answer before I go and do this?
3.22146 times 10 to the 8.
So we got a suggestion right there. So let's see if we catch up. So the decimal right now is here. That's why it doesn't show up. It doesn't have to show up if it's a whole number. So if I start to move it back, that's one factor of 10. 2, 3, 4, 5, 6, 7, 8. I always want to stop when I have a single digit left in front of the decimal. So then I can write that as 3 point blah times 10 to the 8th. Let me write this better. Let me see if I can write this better. There we go. That looks a little bit more like normal, Jeff. Oh shit, I don't want to do that. Yeah, okay. I like it. So now, if you haven't done this one yet, this one's not nearly as bad. It didn't have as far to go. So it'd be 1, 2, 3, 4, 5. So 2.389 times 10 to the 5th. Why are these powers positive?
Because you're moving left to death. Moving left.
Because the number was big. I appreciate that, Boo. When I was young, and I still do, I have trouble with left and right. I just do. For my whole life, it's been exciting for me. So if I'm in a car and somebody's giving me directions, I have to do this in the wheel, and the way that makes an L is left. Have fun with it. I got a lot of other shit in my brain, so I'm okay with having to do that in my life. So I always hated it when they taught me scientific notation with left and right. So I always remember, if it's a big-ass number, big number, positive power. Because when I do this, I want to multiply by 10 over to make it big. So when it's a small number, it's going to be a negative power because I want to divide by 10 over and over and over. All right.
Yeah.
Yes.
When you say big and small, you mean in negative and positive?
No. Relative to 1.
Relative to 1, yeah, same thing.
So like these are big relative to 1. So let's see a problem. I'm almost certain the next problem has to be something less than 1. Let's see if I'm right. Does anybody need that scribble up here still? Scribble is going away. Bye, scribble. Okay. Let's see if I'm right. Yeah, here we go. This seems timely. I'm sure this is exactly what we all want to talk about is viruses. So typical flu virus, which is different than the one we're dealing with, not exceptionally different, but still different, measures between this and this. Meters. So obviously they're very tiny. How would I rewrite this first one? Well, I still have to move the decimal place, but now since they're tiny, it's going to be a negative power. So how many tens? 1, 2, 3, 4, 5, 6, 7, 8. I always have to move the decimal until there's a whole number in front of it. Times 10 to the negative 8, I think I said, right? Yes. Let me stop right now. Does everybody see how I just did that? Does anybody not see how I did that? It's okay if you don't. Okay, all right. So go ahead and do the other one. Oh shit, why did I do that? There we go. Go ahead and do this one. Let me ask you this. You're going to move the decimal until it ends up where?
At the first, to the 2.
I'm going to move it till it's between the 1 and the 2. I've always got to move the decimal so it's got 1 digit left in front of it. So let's see who's got it. What's the power on the 10? How many times did I have to move the decimal? I really hope you guys are with me.
-7.
Yeah, so there's a shortcut to working with powers of 10 because our number system is based on 10. So there's 2 things happening here. Every time I divide by 10, it moves the decimal back 1. So if I move the decimal over, I can see how many 10s did I divide by. And I keep saying divided when there's a multiply right there. Am I okay? Am I feeling okay? Why, when there's a multiplication symbol here, do I keep saying divided on this problem?
Because it's less than 1, less than the whole number.
What part of this tells me that I'm actually dividing, not multiplying? You guys
The
can
negative.
The negative.
negative power, because what would these 10s do? They would actually want to go underneath, right? That's what a negative power means. So I am actually dividing by this many 10s, which is why the number gets so small. So you understand now why I say if it's a small number, the power will be negative, because that only makes sense. I have to divide to make it that small. If it's a big ass number, like the one earlier about how far away Venus is, it's going to be a positive exponent because I actually have to multiply by 10. Okay.
Question, Jeff.
Yes.
Could that also mean less than a whole number?
Yeah, these are both less than a whole number, right?
Right.
Okay. So if the number I'm dealing with is less than 1, the power will be a negative power when I write it like this. When the number I'm dealing with is bigger than 10, then the number I end up with is going to have a positive power on it, right?
Right.
So that's
Also,
what I
have
mean by
one more.
big versus small.
Another question.
Yes.
When it's all zeros, we go to the first number. But when it's 2 numbers right there, because that kind of threw me for a loop, that you stopped at instead of counting the 2, you stopped at the 1.
So again, if I moved the decimal all the way to the 2, doesn't 12 have a 10 in it? I don't know if you guys get what I mean. What does 12 mean? If you break it down, isn't that 110 plus 2 1s? If you really break it down like insane. Doesn't it have a 10 in it? And isn't this notation is supposed to be sucking all the 10s out of something?
Okay.
That's why I always want to stop put the decimal where I have one digit in front of it, so there's no tens left in it. Right? My vampire is sucking that number dry. Ain't no tens left in it. So if you didn't move it far enough, if you stopped in front of the 8, what is 0.8? Isn't that 8/10? Isn't there a 10 in it? Yes, so that's why you always, no matter what, you move that decimal so there's one digit in front of it. That's it. Okay, maybe.
If it's not a 0. That
Well, oh, I see what you mean. Yeah, okay. So it's got to be an actual digit, not just a placeholder 0. You're right. I like it. There's got to be a number between 1 and 9 that ends up in this position. I like it. That's why I have a 1 there. I like it. All right, maybe. So go ahead and do that one for me real quick. Don't say anything out loud. Just go ahead and convert that into scientific notation. So what do you guys get? 7 times 10 to the what?
-6.
-6. Kick ass. So can somebody tell me, good old E. coli, which shows up on our lettuce sometimes and says hello, and the flu virus, which one is bigger generally?
What?
Which one is bigger? The E. coli, because it's
Yes?
yes, because it's closer to the whole number, I would say.
I like it. Yeah, you got it. I understand what you mean. Because it's less negative. It's less small. It's got fewer zeros in front of it. So of course it's bigger, right? So which size? It doesn't matter. That's bigger than either one of these. So a small flu virus, a big flu virus, the E. coli is bigger by about 10 times, roughly, right?
Yeah.
Okay, maybe.
Or 2 10s and the 8.
Yeah, if you look at the bigger one, I'm with you. Somewhere between 10 and 100 times. Or the smaller one, I mean to say. All right, so that was number 6. Is everybody okay with this? You get the basics of changing into scientific notation. And then we have this second level. So there's one level is, can you just change it? And the other level is, can you work with it a little bit? Can you compare them once you've done that? And it is much easier to compare numbers in this notation than it is just to compare a big ass or a small ass number in the wild somewhere. All right, so let me clear this stuff away. It's going away. Bye, stuff. We barely got to know you, stuff. Okay. Blah, blah, blah. Oh, let me see what this is. Oh, shit and a half. Where am I?
You're at 6, I think.
Here I am. Here. You guys do these 4 real quick. Let's see, what time is it? Yeah, do these 4. We'll cover those, and then we'll call it a day. You know, I got to look into that. Wendy, I hope you don't mind me asking this, but does that help your back, sitting on the ball? I'm assuming you're sitting on the ball. Okay. Sort of like, I remember the scene from The Office where I think it was Dwight sitting on the ball or something. Anyway, I was curious about that. I might have to look into getting that. Shit, sorry. This thing is so touchy. All right. This should be a lightning round. Like if you get this idea, you should go pretty quickly. All right. Let me see. I'm going to start catching up with you guys. So what do you guys get for the power on this one?
3, -3.
Yes, -3. I like it. Now somebody else, what'd you get for this one?
It's 10 to the third.
Yeah, 10 to the +3. I like it because this is much bigger than 10. And I always get somebody who has trouble. They say, well, where's the decimal here, Jeff? But I'm hoping everybody understands it's there. It just doesn't need to show up, right? If it's a whole number, why would I need to show it? But I know it's at the end. Same thing here, right? What's really nice is the commas. I could do it by threes, 3, 6, 7, right? So I'll do that one. Now, does it make sense? Does this make sense? If I were, normally I would make this 5 times 10 to the 7th. I would round that sucker all the way down to a single number. Very often we would do that, but it didn't say to do that here, so I'm not going to do that here. And what do you guys get for this last one?
-6.
1, 2, 3. 8 times 5 to the negative 1, 2, 3, 4, 5, 6.
Got it. So 5.8. And by the way, I got to point this out. This notation is the last place you'll ever see us use that symbol for multiplication, right? It's the only place you should ever use that symbol for multiplication. And you all know why, because that symbol now means something very different in algebra. But with scientific notation is the one last place we use that symbol for multiplication. I like it. All right, I think that's enough. We all got to ease back into the school thing after such a long weekend, so me included. So are there any questions about what we just did? All right, I'm going to stop sharing, and then it's officially done. And if you have any questions, hang out and let me know. Otherwise, go do something else.
Question.
Yes.
Like that positive, it kind of threw me for a loop a little bit, but I've seen it. We coming in a positive sense. We going back still to the first number on both ways, regardless if it's not going by 10.
Hold on. Let me make sure I know. Which one are you talking about?
Let's try 54. 54,302. That one.
Yes, the reason that the power is going to be positive on this one is because the number is big.
Bigger, yeah, I get that part, but I'm saying we're stopping at the first number, which is 5.
3.
At the 4,
6,
5, 6,
7.
One more time, yeah, and so same way backwards in the negative.
If I stopped here, 54 still has a 10 in it.
Yeah, we still got 10s left.
So if I did this is interesting. 3, 6, and I stopped there times 10 to the 6. I sucked 6 10s out of it. But there's one more 10 I should have taken out.
Right.
So if I go that, now I've got 5.4 and I've got an accumulation of 7 10s that I sucked out.
Oh, that's good.
Like so
either way, yeah, got it.
Gotta take
that was
all
it.
the 10s out. So this one, I have to move it all the way until it's right in between the 5 and the 8.
And so it's 8 times 5.
Yeah, so it'll be 5.8. Become a 5. All right, Penn.
In the time.
Times 10 to the whatever it was, 6. -6. So to me, the negative and positive would be something I knew. That's the first thing I know. When I look at a problem like this, oh, it's going to be a negative power. I know that already. And then I don't worry about it anymore. Then I just count and I put a negative on the answer I get. This one's positive because it's bigger than 10.
Also, one more question. I don't want to hog all the questions, but do it make a difference if you put 5.8 or 8.5? It got to
Of
be
course it does.
5.8.
Because these are not the same number.
Right,
This one's a little bit bigger than this one.
right,
So that
right,
wouldn't be the same as this. Yeah.
right.
So the order definitely matters. Yeah.
Yeah, okay.
I like it. I like it. All right. Anybody else? All right.
Yeah, I think I was multiplying too quickly, and that's why I said either way multiplication can go. So I was like 8 times 5. It gave me the wrong. Yeah.
Oh,
But
no.
I'm kind of getting the concept, though. I'm getting the concept better.
All right. Good, good, good. Yeah, we still got more to talk about it, so we got some time. All right, guys. I'm going to head out. Have a good rest of your day. I'll see y'all tomorrow. Or, later today if you want. Remember, my extra office hours are today also. Right?
No homework, 1.7, where's that at?
Of course there's 1.7 homework.
Okay.
Yeah, it's on the homework sheet.
Okay,
All right.
page 101.
Sounds about right. Let me see. 1.7. Page 101, yeah, and then page 103. Yep, you got it.
101, 102.
And 103. Yeah.
And then the prep for the 103. Okay.
That's right. Okay.
And then I'll talk to you later about how I'm having a problem on how to get to my, you showed me how to do it. I know I went to it. It seems like I'm not able to get to that, to my homework. And then after you grade it and to see, I go to the module, right? And I hit that.
Yeah.
And I haven't been able to.
But if you go, all right, let me show you real quick. Let me see, hold on. Let me share this. All right, so let me become a student real quick. You can see my canvas, right?
Right.
Let me become a student. I go to something, I go to grades.
I go to
right?
grades.
I pick something that I've graded.
Right.
And then I have view feedback.
Right, I'm
right
not getting anything. Right.
There's a way. So so this nothing shows up here when you do that?
Yeah, when I go, I hit that. Actually, I can do it now. And I don't know, for some reason when I went there, I wasn't getting anything. I was looking for some remarks and so on and so forth. But maybe I'll try again. I don't know, but I know I hit that. And I was like, where's his remark? And it just had a little bitty bar, and that was it.
Oh. So if this top bar does show up, this top bar, where it says Zoom and all that, but nothing shows up, you can hit this button right there and download it. Oh shit, I didn't really mean to download it. All right, go away. So you can hit this button right there and download it, and then just look at it like an image.
Okay, let me see if all right, I'll try that then. And if I have any problems, I'll get back with you.
All right, man.
I just want to see a few things and stuff because it's starting. Some of this stuff is clicking better than others. So, all right, thanks a lot, Jeff. Appreciate it. I don't want to get into the extras. It is what it is, and it ain't what it ain't. Thank you.
All right, Liddell. See you.
All right, later.